Alright, in this lesson we're going to be talking about the two different formulas for geometric sequences. So by now you have already learned what a geometric sequence is. It's a set of numbers that to get each next term you multiply by the same number, or what they call the common ratio. So just to give you a small example, if I had the numbers 2, 4, 8, 16, where this is my first term, this is my second, this is my third, this is my fourth term, and to get each number you can tell that I multiplied by 2 times 2 times 2. So to get each number I'm going to multiply by 2, which is what my common ratio is. So in this case it's 2. So there are two different formulas that you can use for geometric sequences. We have the explicit formula and we have the recursive formula. So the explicit formula here, let's change my color. The explicit formula here allows you to find term numbers by only knowing the first term. The recursive formula here allows you to find term numbers, like in the set, using previous terms. So each have their own benefits depending on the term numbers that you need to find. So let's just review how to find the common ratio with this set of numbers. So I have my set, let me just make this a little smaller here. I have my set of numbers right here. I have -1, 3, -9. And I'm going to look here and say, okay, I want to find my common ratio. So to find my common ratio, you take either the second term divided by the first term, or the third term divided by the second term. You have to take the one higher than the previous one. So like here, I'm going to do my second divided by my first. And I notice that's 3 divided by -1, which gives me -3, which is my common ratio. It's always good to check two sets of terms to make sure that you end up with the same number, so that you in fact know you're dealing with a geometric sequence. So I'm going to now try these two numbers. I'm going to do my third divided by my second. So this gives me -9 divided by +3, which gives me also -3. So that means that my common ratio is going to be -3. You could also do, if you had, you could do the fourth term divided by the third term. Okay, as long as it's two consecutive numbers where you do the higher one divided by the lower one. Okay, so now I'm going to take this same series, or sequence rather. Okay, and I want to find the fifth term. So finding the fifth term, I know that my common ratio is -3. So I might just say, well, it's really easy to just keep finding the next term. I'm just going to multiply by the previous term. So this is where we would say, actually, it might be really useful to use my recursive formula. So the recursive formula says that we need to know what our first term is. That's what this means. And then to find each next term, I'm going to use this bottom equation. So let's write down our equation down here. And I'm going to just get rid of this for right now, so we have plenty of space. So my equation said I need to know my first term. And to find each next term, I'm going to take my ratio times a sub n minus 1. This right here, let me just highlight it actually. This right here stands for previous term. So let me show you how this works. So we know that our first term is -1 here. So if I wanted to find my second term, a sub 2, I'm going to take my common ratio, which is negative 3, and I'm going to multiply it by a sub 2 minus 1, which tells me this is negative 3 times my first term. And how much is my first term? I know that here my first term is negative 1. So my second term is equal to negative 3 times my first term, negative 1. So it tells me that my second term is equal to 3. Cool, that's what I already found out. Okay, I know that from here because we already knew our second term. So we want to find the fifth term. So to find the fifth term, though, first we have to find the fourth term. So we're going to use our formula and we're going to find the fourth term. So I'm going to say that a sub 4 is equal to my common ratio times my third term. We know my third term all the way up here is negative 9. So a sub 4 is equal to negative 3 times negative 9, which is positive 27. So my fourth term is equal to 27. And I wanted to find my fifth term. So my fifth term, I take my common ratio and I multiply it by my fourth term. So I take negative 3 times positive 27, and I get negative 81. So that means that my fifth term is negative 81. Now I can keep going. If I go on to the next example, find the sixth term using the recursive formula. Well, cool, I already found my fifth term, so I can say that my sixth term is equal to negative 3 times my fifth term. Okay, well, negative 3 times my fifth term is negative 81. And I don't know that off the top of my head, so I'm going to use my calculator, my Desmos.com scientific calculator. I'm going to type this in. I'm going to type in, I need negative 3 times, I forget what it said here, negative 81 times negative 81. Okay, it tells me my answer in the corner is 243. So I know that my sixth term is equal to 243. Okay, so that's how the recursive formula works. But now, what if I said my next example, what if I wanted you to find the 20th term for our same negative 1, 3, negative 9, dot, dot, dot. I would say, well, I'm already on a sub 6 from the last example, and that was kind of a lot of work because I have to keep doing the previous term and the previous term and the previous term. So this is where you want to use that explicit formula. So let's go up here, and we're going to write down our explicit formula. So it tells me my term number, my a sub n, is equal to my first term times r to the n minus 1. So let's write that down here. So a sub n is equal to my first term times r to the n minus 1. So remember, n represents my term number, so I'm trying to find my 20th term. So a sub 20 is equal to my first term, which I know is negative 1. I know that my common ratio is negative 3, and I want to find to the 20 minus 1. So I literally just take this and I plug it in on my calculator. I'm going to do a little simplifying first, just so it's a little easier to plug in. 20 minus 1 is 19. So I do negative 1 times negative 3 to the 19th power. So if I go out on my calculator, I'm going to hit enter here. Parentheses, negative 1 times negative 3. And I'm going to hit this guy right here to the 19th power. So this gives me a big, huge number, 1.162 times 10 to the 9. So 1.162 times 10 to the 9. So basically what that means, 1.162. I'm going to move my decimal over 9 spots to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. So my answer is 1.162. 1, 2, 3, 1, 2, 3, 4, 5, 6. This is my 20th term. And that's the difference on using the explicit formula versus using the recursive formula.